Ground fault circuit interrupters, known as GFCIs, provide protection against electrical shocks. They achieve this by monitoring the balance of current flowing into and out of an outlet. If an imbalance is detected, indicating a potential ground fault where current is leaking to ground, the GFCI quickly trips, cutting off the power and preventing a shock. GFCIs can be implemented as either circuit breakers or individual outlets. Arc fault circuit interrupters, known as AFCIs, are designed to protect against electrical fires. They work by detecting dangerous arcing faults in electrical wiring. These arcing faults can occur due to damaged insulation, loose connections, or other wiring issues, creating a potential fire hazard. The National Electrical Code, known as the NEC, mandates the use of AFCIs in bedrooms to mitigate this risk. It's important to understand that installing GFCI or AFCI protection does not automatically convert 2-wire outlets to 3-wire outlets. A 3-wire outlet includes a ground wire, which provides a safe path for straight current to return to the electrical panel, further reducing the risk of electric shock. To truly upgrade to 3-wire outlets, a ground wire must be physically run to each outlet location. This can be a substantial project, especially in older homes where walls may be finished and access to wiring is limited. When addressing bedroom wiring, the optimal approach is to install AFCI breakers to comply with current code requirements. These breakers will protect against arc faults, safeguarding against potential electrical fires. With AFCI breakers in place, the existing 2-wire outlets can remain, but they must be clearly labeled as GFCI protected, since the AFCI breaker provides a level of ground fault protection. For rooms other than bedrooms, the options include installing GFCI protection either through breakers or individual outlets, or maintaining the existing 2-wire outlets. If GFCI protection is chosen, the outlet should also be labeled as GFCI protected. The NEC has specific requirements for GFCI protection in certain areas of a home. These areas include bathrooms, kitchens, laundry rooms, garages, and outdoor locations. These locations are considered high-risk areas for electrical shock due to the presence of water or other conductive materials. AFCIs are specifically required in all bedrooms, including guest rooms and those located in basements or attics. This is due to the increased risk of electrical fires in sleeping areas. If running a ground wire to the outlets proves to be impractical or excessively difficult, consider utilizing ground fault protection devices, known as GFCIs, as an alternative solution. GFCIs can be installed in place of existing outlets. These devices provide shock protection by detecting ground faults and interrupting the circuit. However, it's important to note that GFCIs do not offer protection against arc faults, which is the primary function of AFCIs. Therefore, while GFCIs enhance electrical safety by preventing shocks, they do not provide the same level of fire protection as AFCIs. When making decisions about electrical upgrades, always consult with a qualified electrician to ensure compliance with local codes and safe installation practices. A qualified electrician can assess the existing wiring, identify potential hazards, and recommend the most appropriate solutions for the specific situation. Firstly, ensure compliance with the National Electrical Code, known as the NEC, and any local electrical codes. These codes are designed to ensure electrical safety and prevent hazards. Secondly, prioritize safety by installing GFCI protection in areas prone to moisture, such as bathrooms, kitchens, and outdoor locations. Thirdly, consider the age and condition of the existing wiring. Older wiring may be more susceptible to damage and require replacement. Fourthly, carefully evaluate the feasibility of running ground wires to all outlets. This can be a significant undertaking, but it provides the best level of protection against electrical shock. Fifthly, if running ground wires is not feasible, consider using GFCIs as an alternative. Sixthly, label all GFCI protected outlets clearly to inform users that they are protected by a GFCI device. Seventhly, regularly test GFCI outlets to ensure they are functioning properly. Eighthly, avoid overloading circuits by plugging too many devices into a single outlet or circuit. Ninthly, never attempt electrical work without proper training and knowledge. Tenthly, always turn off the power at the breaker before working on any electrical wiring. The NEC specifies the requirements for AFCI protection in different areas of a dwelling. These requirements are based on the risk of arc faults in those areas. For example, AFCI protection is required in all branch circuits that supply outlets in bedrooms, family rooms, living rooms, parlors, libraries, dens, recreation rooms, sunrooms, closets, hallways, and similar rooms or areas. The purpose of AFCI protection is to detect arc faults, which are unintentional electrical discharges that can occur due to damaged insulation, loose connections, or other wiring problems. Arc faults can generate heat and ignite surrounding materials, leading to a fire. AFCIs are designed to trip the circuit when an arc fault is detected, preventing a fire from starting. There are two main types of AFCIs: branch or combination AFCIs and outlet branch circuit AFCIs. Branch or combination AFCIs are installed in the electrical panel and protect the entire branch circuit. Outlet branch circuit AFCIs are installed at the first outlet in the branch circuit and protect the wiring downstream from that outlet. The NEC also specifies the requirements for GFCI protection in different areas of a dwelling. These requirements are based on the risk of electric shock in those areas. For example, GFCI protection is required for all 125 volt, 15 ampere and 20 ampere receptacles installed in bathrooms, garages, and outdoor locations. GFCI protection is also required for receptacles installed in kitchens that serve countertop surfaces. The purpose of GFCI protection is to detect ground faults, which are unintentional electrical paths that can occur when current flows through a person's body to ground. Ground faults can cause electric shock. GFCIs are designed to trip the circuit when a ground fault is detected, preventing electric shock. GFCIs work by monitoring the current flowing through the hot and neutral wires of a circuit. If there is a difference of more than 5 mA between the current flowing through the hot and neutral wires, the GFCI will trip the circuit. This difference indicates that some current is flowing through an unintended path, such as through a person's body to ground. When upgrading 2-wire outlets to 3-wire outlets, it is important to understand the different methods that can be used to provide a ground connection. The first method is to run a new ground wire from the outlet to the electrical panel. This is the preferred method as it provides the most reliable ground connection. However, it can be difficult or impossible to run a new ground wire in some cases, especially in older homes. The second method is to use a grounding type receptacle that is connected to a metal water pipe. This method is only allowed if the metal water pipe is electrically continuous to the electrical panel. This means that there must be a continuous metal path from the water pipe to the electrical panel, without any breaks or non-conductive materials in between. The third method is to use a GFCI protected receptacle. This method is allowed as an alternative to providing a ground connection. However, it is important to note that a GFCI protected receptacle does not provide a true ground connection. It only provides protection against electric shock. If a GFCI protected receptacle is used, it must be labeled as GFCI protected and no equipment ground. It is also important to note that a GFCI protected receptacle will not protect against arc faults. Therefore, if arc fault protection is required, an AFCI breaker must be used in addition to the GFCI protected receptacle. When installing AFCI breakers, it is important to follow the manufacturer's instructions carefully. AFCI breakers are more sensitive than standard circuit breakers, and they may trip more frequently if they are not installed properly. It is also important to test AFCI breakers regularly to ensure that they are functioning properly. AFCI breakers can be tested using a test button that is located on the breaker. When the test button is pressed, the breaker should trip. If the breaker does not trip, it should be replaced. When installing GFCI outlets, it is important to follow the manufacturer's instructions carefully. GFCI outlets are also more sensitive than standard outlets, and they may trip more frequently if they are not installed properly. It is also important to test GFCI outlets regularly to ensure that they are functioning properly. GFCI outlets can be tested using a test button that is located on the outlet. When the test button is pressed, the outlet should trip. If the outlet does not trip, it should be replaced. In addition to AFCI and GFCI protection, there are other electrical safety measures that can be taken to protect against electric shock and fire. These measures include using surge protectors to protect against power surges, using tamper-resistant receptacles to prevent children from inserting objects into the outlets, and inspecting electrical cords and appliances regularly for damage. It is also important to avoid overloading circuits by plugging too many devices into a single outlet or circuit. Overloading circuits can cause the wires to overheat and start a fire. If you are unsure about any aspect of electrical safety, it is always best to consult with a qualified electrician. A qualified electrician can assess your home's electrical system and recommend the best safety measures for your situation. The selection between GFCI and AFCI protection involves considering the specific hazards they address and the applicable code requirement. GFCI protection focuses on preventing electric shock by detecting ground faults, while AFCI protection aims to prevent electrical fires by detecting arc faults. The NEC mandates AFCI protection in bedrooms and other specified areas to mitigate the risk of fire, while GFCI protection is required in locations where there is a higher risk of electric shock, such as bathrooms and kitchens. Upgrading to 3-wire outlets, which include a ground wire, provides an additional layer of safety by providing a path for straight current to return to the electrical panel. However, this upgrade can be challenging in older homes due to the difficulty of running new ground wires. In situations where running ground wires is not feasible, GFCIs can be used as an alternative to provide shock protection. However, it is important to remember that GFCIs do not offer protection against arc faults. In bedrooms, the primary focus should be on meeting the code requirement for AFCI protection. This can be achieved by installing AFCI breakers in the electrical panel. The existing 2-wire outlets can remain in place, but they should be labeled as GFCI protected to indicate that they are protected by the AFCI breaker. In other rooms, the choice between GFCI protection and leaving the existing 2-wire outlets depends on the individual's risk tolerance and the specific circumstances. If GFCI protection is desired, it can be implemented either through breakers or individual outlets. In either case, the outlet should be labeled as GFCI protected. When making decisions about electrical upgrades, it is always best to consult with a qualified electrician. A qualified electrician can assess the existing wiring, identify potential hazards, and recommend the most appropriate solutions for the specific situation. The electrician can also ensure that all work is performed in accordance with the NEC and local electrical codes. Table 210.21 provides guidance on the maximum load that can be connected to a branch circuit based on the overcurrent protection device rating. For example, a 15 ampere circuit can have a maximum load of 12 amperes, and a 20 ampere circuit can have a maximum load of 16 amperes. Table 310.15b16 provides ampacity ratings for conductors based on their size and insulation type. The ampacity of a conductor is the maximum amount of current that it can safely carry without overheating. It is important to select conductors with sufficient ampacity for the loads they will be serving. Section 250.130c of the NEC addresses the replacement of non-grounding receptacles with grounding-type receptacles and the permitted grounding methods. It outlines the conditions under which a grounding conductor is permitted to be connected to a grounded cold water pipe. Section 406.4d2 discusses the replacement of receptacles and the use of ground fault circuit interrupters. It provides guidance on the installation of GFCI protection in certain locations. Article 547 addresses agricultural buildings and the specific electrical requirements for those buildings. It includes requirements for wiring methods, grounding, and equipotential planes. Understanding these code sections is crucial for ensuring electrical safety and compliance during electrical work. Always consult the latest edition of the NEC and any applicable local codes for the most up-to-date requirements. Electrical work can be dangerous, and it is always best to consult with a qualified electrician if you are unsure about any aspect of the work. A qualified electrician can assess your situation, provide expert advice, and ensure that the work is performed safely and in accordance with all applicable codes.